Hey, data builders! Welcome to another deep dive session where we'll turn your timestamp nightmares into data engineering dreams. Myself, Kamesh, lead developer advocate at Snowflake, tuning in live from Bangalore. If you ever fought with temporal data and thought there should be a much better way than doing group by timestamp trunk, you're in right place. So let us explore together time series analytics in Snowflake, and I promise there is going to be zero undefined not a function moments. So what's in our Git commit today? Timestamp sync that will make your data historians jealous. We're going to do range between to handle tricky aggregations, as of joins, making sure that time travel is not just for sci-fi, and real world patterns that's going to help you handle late arriving data. Drop table if exists, boring sessions, and create table awesome knowledge as select star from today's topics. Bring your questions, use cases, and burning production issues because we are going to have someone special today who can tackle them all. I'm thrilled to welcome Yogita, our expert speaker, Yogita Chilukuri, product manager focusing on time series analytics at Snowflake. So when it comes to turning temporal data challenges into opportunities, you're going to learn from someone who is actively building the future. Fire up your SQL editors. We're going to have something cool in our Git today. Over to you, Yogita.
Thank you, Kamesh. Happy to be here. I'm a product manager here at Snowflake. Work with time series data and converting or building some functions that helps working with time series data easy, and also overall work on the SQL developer experience. So feel free to ask me any questions or share your challenges that you're facing with time series data or otherwise, and happy to answer them or take feedback from here.
Awesome, great. I think people will be fired up to see your code, what you're going to talk, the demo that you're going to show people, like all the things that we're going, the cool things that you guys have been doing around analytics. I'm really pepped up to see what's in store for us.
Awesome. All right, I think maybe to begin with, I'll set some context, talk a little bit about what have we been doing in terms of time series analytics, how have we made it easier. But even before that, let's talk a little bit about what is time series data. It can mean different things in different organizations, but what do we really mean by time series data and time series analytics here at Snowflake? So what is time series data? It's usually a data set that captures how a particular system, process, or behavior evolves over a period of time. Usually contains three main aspects. Like one is your date or time. It could be timestamp as in this example, or it could be date, year, month, however you're capturing that time component. The second is a system identifier. In this example, it's a sensor ID, but it could be a stock ticker or it could be a machine ID, something to identify the system you're talking about in this time series dataset. And lastly, your values. It could be a long list of values like here, which is temperature, humidity, etc., or it could be a long JSON, semi-structured data, which captures all of these metrics that you are interested in. So these kind of data sets, time series kind of data sets, are spread across industries, and everyone is trying to gain or get value from these data sets because they're super critical. For example, an analyst in a financial firm might be looking at stock buys, bids, trades to see if a transaction or a trade that was made is actually a good one in retrospective. Or maybe an engineer on a manufacturing platform could be working on combining their IT data with OT data and building analytics such as exception-based surveillance, predictive maintenance, or energy efficiency modeling. Similarly, if a developer on any software developer on any in a large firm might be collecting all their application log data or network data or server data and using all of this information, which is usually time series data sets, to for infrastructure monitoring or resource allocation, etc. So all in all, these kind of data sets and use cases are spread across industries. It could be that a marketing team is using this campaign information to see if a campaign was actually an effective one. Feature stores are also using these kind of data sets to build feature stores and also update them in a timely manner. And we've seen that these data sets are also used for building very important data pipelines that are used for downstream analytics.
Okay.
So
So just sorry to interrupt you. Like since you're talking about time and time series and then the use cases across, so it's a time end of the day, right? So what is these challenge that we usually see with these ones? Because I see like always like I've seen when I'm doing programming and when I'm doing something like always hit up bump with timestamp related challenges. So what is specifically you see that why we need something specific like time series analytics or something specialized functions or specialized methods or whatever we call as like to kind of handle these data.
great question, because we work with time series data sets so often, and we run into challenges. But like, if you were to put them into certain buckets, right? Like there are four main challenges that we've usually heard from customers. The first one is with respect to the quality of the data itself. We see that there could be missing data or there could be duplicate rows. Like, how do you handle all of that in an efficient manner? Like we also said, like, these data sets can be coming from various different sources. And you need to combine all of these data sets in a correct manner such that, we can do analytics on top of it. Third, imagine a sensor is like emitting readings every few milliseconds or even seconds. Imagine the size of the data sets. These can be really, really large, so we need a platform that can handle this large volume of data and also like help us to do analytics in a price performant manner. Lastly, to derive value from this data, you might have to write like really specialized functions or to gain value, and this could be a long SQL code or long Python code. So you might need specialized skills to actually gain value from these data sets. And we recognize all of these challenges, and that is the main reason we've built these time series functions to address some of these challenges you run into every day while working with your time series data.
That's awesome. I think so. When you say native time series capabilities, and then I really like the last part where you're talking about okay, we have some specialized skill set, right? That's something like I think probably I just want to just double check with you. Like it doesn't mean that like people who are using these time series data like they're always doing complex stuff, right? Because it's something like we want to spend time on more efficient and other important stuff rather than just working with just a small piece of data like a time data and then spending more hours lines of boilerplate code to do the same stuff, right? Is that what if is that what I inferred when you mean by specialized skill set, right? Other than that, like it's going to be the normal skill that the developers has, correct?
Yes. So one thing is like, like something which you'll be doing very often. We want to abstract that, give you easier functions to, do those kind of things very easily. You don't have to write the same piece of code, like you said, Kamesh, like again and again. Whereas in other cases, you might be writing really complex code. For example, like, we'll talk about proximity based joins. When things don't align up exactly, how do you do that? Like, how do you do these kind of joins? And you might have to really write a long SQL code with left joins and then make sure all you're doing this correctly. So we want to also simplify those kind of workflows and provide you an easy syntax, which is not only easy but also performant for doing such kind of operations. So we want to handle both of them, like remove your boilerplate code, make it easy to work with your data in such cases, and also handle your complex scenarios and build a function that'll make working with time series data easy as a whole.
Amazing. I think I'm just looking forward to what's in store. Like, yeah, can you? I think, yeah.
Yes. So we'll talk about mainly three things that we have, native functions that we have introduced recently. Or so the first one is time slice, second one as of join, and the last one is range between. We'll talk about each of these in a little more detail in the following slides. But feel free to ask any questions if you have about these functions or working with time series data sets. So first one, time slice. So this falls into that category where you want to do a simple operation and you do not want to keep writing the same piece of code again and again and again. So for example, it's very common that you're interested in looking at or understanding your data in terms of buckets, and not looking at point in time values. So what you want to do is bucket your data, do some aggregations on top of that, and look at those aggregates, how those aggregates move over a period of time. The second is that we said time series data sets can be really large in volume. What you might want to do is you do not want to store all of those minuscule pieces of information, but you want to store only the aggregated values. So in both of these scenarios, we've built a function called time underscore slice that helps you do this very easily. So, as an example, if there's an engineer who's working to understand how the user behavior changes in a daily fashion, they can easily use time underscore slice function to bucket the data. So they would say time underscore slice. In the first argument, pass the date or time column. Here it's the timestamp, and specify the bucket width. Here it's 1 day, but it could be, let's say, 10 minutes or 10 seconds or even a year, like whatever be the granularity you're interested in. And then specify the aggregations on top of it, where they can, in this example, find the number of active users or the average session length for a user in that day. And they can do this all of this very easily by just writing this time slice function to bucket data. So I hope that was clear about using, how to bucket data using time underscore slice. This is a function which is used widely by customers, and I encourage everyone to give this a try. So the next one, this is one of my favorite functions, which went into GA around became generally available in May of this year. It's the as of joins. So if you're working with time series dataset, you might run into a scenario where you want to join 2 or more time series datasets to get value from your data. But you'll run into a scenario where the timestamps in both of these data sets might not really align that well. It could be for several reasons. It could be because the sources that are generating these data sets, they have generated at a different cadence. Or you use the time slice functionality that we talked about earlier to bucket your data sets in a different granularity. Or it could be the simple reason that there was missing data. It happens very often, like when the sensor is dead and we did not get readings for a period of time, or there's an outage and we don't have readings for a period of time. So there is, whatever be the reason, there is no way to do an exact match and join these two data sets. So what we need in that kind of a scenario is a proximity based join. So for what we do in as of join is, for each record on the left side of this join, we find a record on the right side which is the closest match, and you can tell us how you want to find us to find the closest match. So is it the following record, or is it the record just preceding this record on the left? So you can tell us this join condition. So also this functionality is available in SQL that we are seeing here, but is also available in Snowpark if you're using Python for your code. So let's see this through an example. Let's say for regulatory purposes, a finance analyst wants to find the closest stock quote prior to a stock trade. You'll see that this can be done very easily using this as of join. So you'll join your trade data with your code data and align your two data sets using this match condition. And you're joining on a particular stock symbol. So it could be, let's join on Snowflake stock symbol or Meta stock symbol, whatever you're looking at. And I won't read each of these quotes given by the customers, but overall we have seen that customers love this functionality, not only for its ease of use, but also it's very efficient or performant compared to several workarounds that they have today. So this falls into that second category, Kamesh, that we were talking about, that this is a complex or a cumbersome operation that customers have to write today. But when they replace this complex workarounds that they used to have with this native functionality that we provided, they saw that their performance improved. So it was not only easy to use, but also very performant for them to use.
Yeah, I think one question I have around SF Join, if you can go to the previous slide, just for the interest of everybody, might what if in the next one, like what if we don't have a matching condition, right? Like let's say I have one set of records which has, like, there is a day difference between each of those records than the other one, right? Let's say I'm doing, for example, like we have our own tasty bites thing which you always do, right? Let's say, imagine, like, I'm kind of going and finding, I'm a kind of running a restaurant. I have some trucks which do stuff for me, right? And then I have some menu items where we buy. Everybody who is listening to this, like, probably they won't be aware of Tasty Bite stuff. So let's say I want to do something like an analysis of records between sales and the trucks, and then find out, okay, how many days, or like how many trucks has been there against the sales that is being done, right? So is that a classic case for SF Join? I'm just asking you, like, if that's going to be a case, like if I want to do a relative analysis, if you call them as, right, if procuring of my trucks plus procuring of my sales, if that's going up or down, I want to do that analysis. Is that a classic as of join case, or is this both as timestamps in them? And then I want to do a timestamp based last quarter or last 2 quarters or last 3 quarters type of stuff. Is
Yes.
that a classic?
Usually that's a typical case where you want to analyze two data sets. Like here in this example that you mentioned, I think you said you had the sale data and also, let's say, some truck order data. I'm assuming that's the thing. So you want to say for some reason diagnose the sales went down. What was the last buy that happened in this particular truck? So what you would do is join on that truck ID and find out like what was given this day. Like let's say today is 22nd of October. So what was the last buy that happened on this truck? Does that give us some information? Like you could use that, or you could aggregate all your buys that happen on that truck, and then join using an as of join to do some proximity based, seeing that what was the last thing that happened on this truck. Is there some discrepancy that we see? So you can use that for such kind of analytics. So like you said, like it's also very often used for determining hey, user went through this funnel, entered this page, then clicked on this icon, and then did this action after that. So it's used for doing this kind of funnel analytics. Like what is the next action, and is this can we determine something from these? Like what is the next action? Like using an as of join, you can see if that gives us some insights as to if a person clicked, if a user clicked on a certain button, it will usually be this will be their next action. So you can do such kind of analytics using an as of join.
Yeah, that's great. I think probably that get some idea for people. When I think for that, I think you can just go ahead, Yogita. I think that sounds good. Yeah.
Yeah, for also the purpose of just clarification, and also to share some more use cases, if that helps, which understanding this as of join where it could be used. It is we talked about this use case of predictive maintenance, right? So whenever there are two data sets in this manufacturing world, where one is the maintenance data and the other one is the equipment health data. And let's say an engineer wants to understand if just before the maintenance, what did the equipment health look like? So they would join this maintenance data with the equipment health data and look what the health looked like just before maintenance, to see if they can derive some patterns. So those are some typical kinds of use cases where an as of join would be really, really helpful.
Awesome. I think that sounds great. I think there's a lot of opening there. Yeah.
Okay. So the last one is this range between functionality. This one is a simple functionality, but several customers struggled with using, or because of the lack of this, for several years. So what we do in range between is when working with time series data sets, it's often the scenario that there is missing data for a few days or a few seconds, a few minutes. So this could be because, let's say, the sensor was malfunctioning and there was no data that was generated, or there could be an outage because of which we have not received the data. Or it could be that it's an expected gap in data. So let's say in the stock trading scenario, it's a weekend and there's going to be no trades on that day. So that's why we see no information. So whatever be the reason for the gap in the data, we need our analytics to be aware of the gap and make sure that we are considering that while doing, let's say, calculating moving averages or moving sums. And calculating moving averages, moving sums is such a common operation. You'll see all our dashboards, have these moving averages to see if there's an anomaly that comes up, or how are we trending, etc. So before having this range between functionality, customers had to make sure that there was no gaps in the data. They had to pre-process their data, for example, and have a uniformly distributed data set, and then use rows between window frame functionality on top of for their analytics. But now with range between, all you have to do is, say, you're interested in calculating the oil production over a 3-day period. You can simply say range between interval 2 days preceding and current row. So, and if there is gap in data, there's, let's say, missing data for one of the days, we will take that into consideration and make sure that the analytics are right. So it seems very simple. So you no longer now have to pre-process your data or be worried that there might be gaps leading to incorrect results, or remember which data sets have gaps and which data sets do not have gaps. So we have you covered, and you can do so easily with this range between functionality.
Awesome. I think that's great. I think just one question before you actually move to your demos and other things, right? So are we it's recommended, are we good to kind of use these functions in combination together? Let's say I can put a range between plus as of plus time slice. I'm just taking a very crude question, right? If there is a use case where we might need to use all these three things together, is that recommended, or it's that something we don't recommend, or is very complex, or it makes things super hard or something like that? So is there something we can do?
Yes, absolutely. And we see our customers use all of these in together. So in the demo also you'll see me using as of joins, and then followed by a time slice, for example. We see several queries that come which have all of these put together. So you can go ahead and use this all of these functions together.
Awesome. I think that sounds great. I think one question, like we just saw three, right? I think since you flipped this slide, it's another question that I have. Like, is these are the only functions that we use, or we have an array of functions we can find in our documentation or wherever it is, like which is like for windowing, for slicing, and other stuff for
Yes, we
doing?
have a long suite of functions, Kamesh. Like we can use all of this. We've seen customers use all of these together to onboard their time series analytics workloads to Snowflake. Like we'll see customers using lead, lag, min by, max by. So we have a long list of functionalities, and we spoke only about three of them. So I encourage all of you to go through our documentation and read through these functionalities if they make sense for you.
That's great. I think awesome. So it's a demo time now, yeah?
Yes. So I know we have only like about 7 minutes. So I'm going to fly a little bit through this demo. But I'm using our notebooks today to demo these time series functions that we talked about. So the cell here is basically the setup that, bring in some packages that we need for this demo. So two use cases that I wanted to cover. One is in the financial services world, which is transaction cost analysis using the as of join functionality that we talked about. You'll also see the usage of time slice in that. The second one is a simple, IoT analytics range between functionality that you'll see. So for the financial services use case, I use the FactSet. There's a stock ticker trade data set available, made available by FactSet. I have used that data set for our analytics. I've also pre-processed that data so that it's easier to work with for the purposes of this demo. So some things that I've changed that to keep in mind is that, the initial data set has the time in integer format. I've converted it into timestamp, and I've also filtered the meta traits for the purpose of this demo. So, all right. So the first pre-processed data set that I have is the meta traits. Here are 5 records, sample records from this data set. So if you see it, what it has is the timestamp when the trade was executed, what was the price at which it was executed, and the volume or number of shares that were bought. And you'll see that this is actually, there are 35 million rows in this data set. So not a gigantic data set, but enough for the purposes of our demo. And also, we have this data set, which is meta closing prices, again, derived from that FactSet data set. This essentially captures what is the 4 p.m. closing prices for Meta over a period of time. So it just has the closing price, the ticker name, and the timestamp. So these are the data sets we'll be working with for our demo for the financial services scenario. So let's say an analyst, to set up a scenario a little bit, an analyst wants to compare the trades alongside some benchmark data and see how the trades are performing and see if there's any anomalies that come up. For this, as of join is a perfect candidate to do it with. So let's say for our demo today, the benchmark data set that the analyst is using is just the closing prices of Meta. And they're looking at Meta dates, Meta stock trades particularly. And for doing this comparison of the actual trades with these benchmark trades, they can easily do so using the as of join functionality we talked about. So all they would do is the meta trades, as of join, the meta closing prices, so the benchmark data set, use the match condition to align both of these timestamps in both of these data sets and join on the stock ticker. Here we are only looking at meta trades, but let's say this actually in a real world scenario, it would have all different stock tickers, and you're joining only on the meta trades. And you'll see that the output data set has the trade timestamp, the price at the trade price, the closing price. The price impact is nothing but the difference between both of these values and also the volume. So you'll see that, as of join makes it incredibly easy to do these kind of proximity based joins, which you might do every day, day in and day out, or you might need for several of your analytics. And also, it's very performant to do these using this native syntax versus any other workarounds that we had earlier. So now that we have the price impacts, then an analyst might want to analyze it and, against several other metrics. So they might want to analyze it with respect to cumulative price impact or the average trading prices. For that, they will use the time slice functionality to, bucket the data into a daily fashion and then calculate these aggregate values and see how the price impact changes over a period of time. So in this first case, they easily calculated the price impact using the as of join functionality. Now they're bucketing their data by time slice into a daily fashion. And now for visualization, here is how the price impact looks over a period of time. So this is a scatter plot where anything above zero means a positive price impact, usually indicating a bullish sentiment or aggressive buying. And the negative price impact usually indicates a better sentiment. So they can look at the scatter plot to see if there's anything that stands out and go further into analytics. So maybe they would want to analyze if this, looks odd, and do more analytics from there. So this is a simple use case, and they can do this kind of transaction and cost analysis and compare it with respect to any kind of benchmark data sets that they have or analytics that they want to do. And this is super, we've heard from customers that this is super easy to use and also performant. And the second scenario, switching gears a little bit, let's move into IoT analytics a little bit. So let's say we have IoT data and we wanted to analyze that data. So we'll see that there are scenarios where there are gaps in data. So you'll see that this data set there's a sensor which is sending these metrics every 5 seconds, but there is a gap in data. Let's say you'll see that at 20 seconds there is no data. This could be because of several of the scenarios that we discussed earlier. But let's say this analyst wants to understand how the 5-minute temperature readings changes. They want to bucket by 5 minutes and see how that varies over a period of time. They can do so easily now with this range between interval 5 minutes preceding and current row. And let's say, plot it in a graph and put it on their dashboard and see if anything out, they can set up alerts to see if any anomaly happens and do further debugging from there. So this is the demo that I ran through, but we are happy to share the resources. We have all of these demos built in, and you can execute them by yourself. But it basically shows how you can do these kind of analytics very easily using the native functionalities that we provided.
Yeah, I think thanks so much, Yogita. I think we just at the top of the hours, so probably I would see if there is any questions that we have from the participants that we can take before we can share some links for them to go see the stuff and all these things. So, but while that happens, when the questions get popped up, probably I have one more question right on your demo, saying hey, when we have timestamps, it's all timestamp columns, right? So when we have a timestamp column and then assume that I have various time zone data being brought into my table. So if that's the case, then do I definitely it's better to use no timestamp, no time zone kind of thing on this, or what's your advice on that?
So it depends. Like we have three types of time zones supported, like no time zone, local time zone. No time zone is just the wall clock, like local time zone. So you can choose whichever format that you want and specify the data type and store that in your table. So it'll be of all single type, and then you can do conversions as you see fit. So it depends on how you want to store it, and then your analytics will take care of will consider that while we are computing.
Okay, that's great. I think that sound awesome. I think since we are on top of the hour, probably I don't think so. We have any questions? Ed, I think yeah. I think there's one question from Anthony. Is this generally available now?
Yes, everything that we discussed today is generally available.
Awesome. I think that's one question. Thanks, Anthony, for that. I think that's pretty much we have. Probably like I would love to see if I can share some links for people to get started. The one that you see on my page is all the official documentation links that you see on Snowflake's official website. I'm just going to zoom that in for you people to see this. That is one. There is one there. There is one time series analytics with pricing. I can go to developers.snowflake.com solutions and you can search for this. You get this one, and that's going to be one which is going to be for the actual documentation. So that's going to help you with doing this one here. So I think probably I'm going to do this like this way and then share it across. There's going to be a time series data user guide from our official documentation that you can see that, and there's a lot of stuff there. In fact I personally went around and saw that like before this particular thing. I think probably you can check that one as well. And the last link before we sign off is again there's a quick start. If you want to go to quickstarts.snowflake.com and just do a time series search, you should be able to see this quick start coming up, which you can try out all this thing that Yogita was talking just ago and all the functions and even more than that, plus few more links for you to start with. I think, in fact, you can see the whole bunch of links that you there on the screen, like the screenshot of all the functions that we shared. You can see those as well. I think obviously we can hit on us like on our user forums and other places where you can get answers on this. And then that's pretty much it. Since we are a couple of minutes over, probably I would like to thank you all for joining us again for another YouTube live session, and looking forward to join you all for the next one. And thank you so much, Yogita, for joining us today and sharing your knowledge. And I hope there's a lot more things to come on time series analytics at Snowflake. And
Yeah,
thanks everyone,
thank you.
wherever you are. Good night, good day, good morning. So I should say good night since I'm totally on the other side of the zone. So see you all in another YouTube live session. And thank you so much. Thanks, Yogita.
Thank you.